let's look at the two transistor modes of operation. Modes of operation. What do I mean by modes of operation? The transistor, here's how a transistor works. The transistor is either going to act like an open switch, so think of my hand as an open switch, or it's going to act like a closed switch, okay? And the beauty of the transistor is that it can be totally closed, totally open, or partially closed. So this is how a transistor behaves. Fully open, fully closed, or in between. That's how a transistor works. So when it's fully open, we say that the transistor is in a cutoff mode. So that's what we show on page 8, figure 12. The first mode is called the cutoff mode. What do we mean by cutoff? That's when the transistor behaves like an open switch. So that's called the cutoff mode. So when would a transistor act like an open switch? An open switch basically means that there is no current flowing in the transistor. And the current in the transistor is IC. And IC cannot flow if there is no IB. So that's what figure 12 shows. It shows IB is equal to 0, which results in the transistor collector to emitter. Here's the collector, here's the emitter, behaving like an open switch. So that's what we show as far as the transistor is concerned. There's my collector, there's the emitter, okay? It's going to act like an open switch. Can any current flow in an open switch? No current can flow in an open switch. So IC is 0. So this is called the transistor acting like an open switch, and the technical term is it's in a cutoff mode. Okay? So that's the first operation. Next operation. The transistor acting like a closed switch. So we're looking at the two extremes first. Either fully open or fully closed. So this is fully open. Now let's look at fully closed. If it's fully closed, then it's going to do this. Collector, emitter. That means that I have opened up my tap here. The tap is open. Current's flowing into the base, which is causing the collector current to flow. And if that collector current is maximum, so that the transistor acts like a closed switch, the voltage from the collector to the emitter is equal to VCC. Look at this circuit. Look at the circuit on the right. If I replace this transistor with a closed switch, okay? No. I made a mistake. VCE here is VCC. When it's open, the voltage across collector to emitter is VCC. When it's closed, what is the voltage across a closed switch? 0. Right? So when it's closed, then the voltage is 0, the current is maximum. IC is maximum. When it's open, the voltage across the transistor is equal to the supply voltage, VCC. So that is what figure 13 shows, is the transistor acting like a closed switch, and IC in that circuit is VCC over RC. Okay, so these are the two extreme modes of the transistor, either fully open or fully closed. So what we can do is we can use, this is called, so this mode where the transistor acts like a closed switch is called its saturation mode. Cutoff mode, open switch. Saturation mode, closed switch. Okay, so that's the technical term used for the behavior of a transistor. So the top half of page 8 shows the cutoff mode, the bottom half shows the saturation mode. So now let's go to the next page. What it shows is the characteristic curve of the transistor. What do we mean by the characteristic curve of a transistor? Well, if you recall, we've come across the term characteristic curve once before when we were talking about diodes. With a diode, we said that a characteristic curve explains to us how a diode behaves. And that is with a graph that I draw like this, where this is V forward, I forward in the case of a diode. And we said, as soon as I get to how much? What voltage? 0.7. As soon as I get to 0.7, current begins to flow in a diode. So that's my forward mode. Reverse mode, no current until breakdown. So this is breakdown. Right? So this is called the characteristic graph of a diode. Similarly, we're now going to draw a characteristic graph of a transistor. And first, we're going to draw the graph of the NPN transistor. So, what we do is we draw a graph like this, horizontal, VCE, vertical, IC. Okay, with a 0 here. Why are we interested in VCE and IC? Because that is the voltage at the transistor, collector to emitter, and that is the current in the transistor, IC. So those are the two most important parameters of a transistor. So let's look at the first case. Cutoff, open switch. Current is 0, voltage is VCC, which is this value here. So what I do is I show a current of 0. Where is the current of 0? Down here. So at that point, my voltage collected to emitter is VCC, the supply voltage on the collector. So I call this the cutoff point. That's cutoff. Okay? So that's 1 point. That's when the transistor is fully open. Now let's take the second case. Saturation, where the transistor is closed. When it's closed, the voltage is 0, but the current is maximum. Where's the voltage of 0? Right here. Where's the maximum current? Some value up here. So this is saturation.